Welcome everyone. So first of all, the question that's posed there, why is that an important question? So it's something to ask ourselves to begin with. And the answer to that really is because the Central African Copperbelt, or we'll call it the Copperbelt, hosts the world's largest sedimentary hosted copper deposits in the world. And it's the premier district for said hosted copper. It also is that style is the main source of cobalt to the world, and this district being the most significant district for supplying the world's cobalt. So not only that, but it's also because the Adelaide Riff complex and associated sedimentation shares many characteristics with this region. So, we're known as an ISCG province, being prospective for ISCGs. Could South Australia be known for hosting significant said copper deposits? It's an important question to ask. So not only that, but there's also real strong demand, which Peter's kind of alluded to over the last few years for copper and cobalt, really buoyed on by high commodity prices. There's been a real push for said copper in South Australia over the last few years, and I've just got up there a few, some highlights. I'll just point out the CODA being weeks away from announcing JORC compliant resource for Emmy Bluff deposit. That would be the largest resource we'll have, said copper resource we'll have in South Australia. There's also some really interesting results from the southern Flinders from Taruga, and not only good copper intersections, but quite interestingly, pretty high rare earths. We had a little bit of a discussion about that at the said copper workshop, and this is something that's not really that well talked about, but those types of fluids do liberate rare earths, so that's another opportunity associated with these deposits. And also, as Mai mentioned, over the last few rounds of, couple of rounds of ADI, there's been a number of said copper projects that have been supported. So with this interest in said copper, there is a bit of a question of, what can the survey do to support this? And that's really what I want to talk about today, and really tell you and explain just how prospective SA is for sediment-hosted stratabound copper deposits. So in this talk, I'd like to give you the evidence why SA is prospective for this style of deposits, and those described, the range of styles that are described from the African Copperbelt. Talk to you about the GSSA CSIRO project, where we're looking to address some of the I suppose, challenges to successful discovery of this style of deposit. That project led by Carmen Cruft, and end with highlighting some opportunities which I can see and were discussed over the last couple of days. And I should mention that we're not reinventing the wheel here. This is not, as Paul mentioned, many people have thought about said copper in the past in South Australia. Many people have talked about the analogy between the African Copperbelt and South Australia. A lot of great industry campaigns over the years, and I highlight the Amira project there as a reference where, to some extent, they did draw that comparison with South Australia and over a few years, and did some really good work. So first, to get everyone on the same page, just to talk about what is a said hosted stratabound copper deposit. So they range in the name of them, the styles. So the names really range depending on the stratigraphic level they're in, the host rock that they're in, and so they go across a number of synonyms. But essentially, the deposits form through the stewing of brines within an intracrotonic basin, or thought to be an important control. And these stewing of brines, circulation cells form from having a seal in a deposit in a basin, and extracting copper from mafic units, and also within basement, interacting with basement in that basin. And it's that stewing of juices that extracts the copper and oxidides fluids, moves it up structures, and as soon as it hits a reducing agent, it drops out. And so growth faults are important controls, and the margins of the basins are seen as being key areas for focusing the precipitation of copper sulfides. So in a lot of ways, it's got some similarity, a lot of similarities to petroleum systems. So the Katanga Basin, the African Copperbelt sits in that, formed during the Rodinia breakup. And at the same time that was happening in Australia, we were forming the Centralian Super Basin, and then in South Australia, forming the Adelaide Riff complex and associated depositions such as the Stuart Shelf of that basin depositing over the Gawler Craton. So the tectonic setting is an important control, and you can see similarities in timing of formation of these basins for the Copperbelt and the Adelaide Super Basin. And because of the similarities in timing, you get similar climatic controls, and we have very similar depositional histories in the Katangan supergroup and the Adelaide Super Basin. And I'll just go through some of the key components, and while I do that, I just want the Hitzman model that's in the top there, just keep those different segments of that model in mind. So we start with the deposition, the Riff phase of coarse clastics and evaporites, and mafic igneous rocks, so source rocks. And it's really important, this phase of the basin evolution and deposition, to get lots of salt into the basin. So both basins have that. Lots of evaporites. We see lots of diapirs in the Adelaide Riff complex, proof of that. You get renewed extension in the basin history, and that's the Burra group. And finer clastics, carbonates, and magnesium-rich fluids are important, and we've got plenty of examples of that, of magnesite deposits in that Burra group. So these are the Riff phase, where you're really loading up the basin with some of those the metals and ligands to extract those metals. So it's the Kalana group and Burra group in South Australia. We move up to the Sturdian glacials. The African equivalent is the Grand Conglomerate, and that hosts the giant, supergiant Kamoa-Kakula deposit, which is actually similar in size in some ways to Olympic Dam, so it's comparable to an Olympic Dam in terms of contained copper. So that's our Sturdian, our pilotilite. Moving up, we've got Sil carbonate, where quite often you get deposition of copper, and the Cap carbonate after the Maranoan glaciation, which is our Nuckalina dolomite. Followed by an orogeny. Both have a similar timing on orogeny, the Pan-African and the Delamerian orogeny, and in Africa this plays an important part in remobilising previously formed deposits. So just bring up the location of copper mineralisation. Have to note that in Africa, a lot of the major deposits are found in the lower part of the stratigraphy, but throughout most of that lower and central part of the stratigraphy, and the same thing is seen in the Adelaide Super Basin. I knew Carol from GA would be watching, so I thought I really had to put this in, and they have done a fair bit of work looking at the relationship between, and Steve's in the audience, looking at the relationship between base metal deposits and changes in thickness of the lithosphere. And both the Adelaide Riff complex, or really the Stuart Shelf, and the African Copperbelt sit on these steep gradients. On top of that, both regions have been talked about as having very enriched subcontinental lithospheric mantles sitting underneath them. In terms of ore textures, so these deposits typically form fine disseminated mineralisation along bedding. It can actually be quite difficult to see in a lot of cases. You also get it replacement of cements and filling of pore space and breccia infill and veins. And we see all those textures in South Australia and South Australian examples. And these are all classic textures of this style of deposit. So that was at the macro scale. At the micro scale, a number of images here from thin sections where, again, it's demonstrating the process that occurs to form these deposits. So you get syngenetic, at the sea floor, you're getting framboidal pyrite, or during early diagenesis, you get sulfate reduction, which forms early pyrites. Then through that sulfate reduction, or the diagenetic phase, you get dissolution of carbonates, which opens up pore space. So that's a secondary porosity, and within that porosity, you fill those up with reduced fluids. You then introduce an oxidised copper-bearing fluid, and these replace these early pyrites and also form in that pore space. So these all happen during the dewatering of the basin. And so in thin section, we see these same textures happening. So these are all from South Australia, beautiful framboidal pyrite, particularly in the one with the black outline there, if you can see that. Framboidal pyrite replaced and rimmed by copper sulfides. Important in terms of demonstrating that these processes are taking place in all the South Australian occurrences. So if we think of the Adelaide Super Basin and think about said copper in terms of mineral systems components, the Adelaide Super Basin ticks a lot of the important boxes, including the demonstrated copper enrichment and occurrences. So there's just from SARIG a map of all the copper occurrences in South Australia. You can see the Adelaide Riff complex lights up, and yes, there's a control there of being close to the surface in that region, but it really does emphasise the amount of copper that's being mobilised in that region. And we've recently done some work trying to classify the deposits and pick out the ones which are said copper. In actual fact, it's over 40% of South Australians' total copper occurrences are of the sedimentary copper style. So a lot of those are pretty small, so you have to ask yourself, where are the actual giant deposits? So this is a great cartoon by Gayling and Droser of the Adelaide Riff complex and shoulders, and demonstrates some of the processes. So the pink bits there are the salt-rich it's really, the copper precipitation is really out on the shoulders of the deposit, around dye piers, around reactive rocks and in reducing units. And that's exactly where we see all our major and minor copper occurrences. But the major deposits in the African Copperbelt and the equivalent of the Zambian province is really on the shoulder, which shown by that green arrow there, which is our Torrens Hinge Zone. And unfortunately for us, a lot of that is quite deeply buried, but in actual fact, some of it is closer to the surface, and IGO talked to us yesterday about their exploration in the southern part of the Torrens Hinge Zone. We really look forward to following the results from that. There is a bit of a question mark in South Australia in terms of, were those saline fluids, did they breach and get out to the Stuart Shelf? Because that is where South Australia finds, we see at this point, our biggest deposits. And it's interesting if you have a look at a model for the basement proximal Zambian Copperbelt there on the left, where they show a summary of the kind of architecture that they see: basement highs surrounded by red beds, overlain by reduced facies, and how similar that is to the Stuart Shelf, where we're seeing basement highs both of basement and Pandara Formation in the Panadi High, and overlying reduced facies. Not only that, in terms of the similarities, but in actual fact, the Copperbelt, they talk about a lot of basement mineralisation being of the ICG style as well. So there's, when you look into it, there's a lot of intriguing or compelling similarities. So, buoyed on by this interest in said copper, and really asking ourselves, well, what can we do to have an impact, a positive impact to exploration in this region? We put together a project between CSIRO's Basin Analysis team and us to really try to see what we can do to improve exploration success in this region, and probably maybe even try to find other areas that should be the focus of exploration. So the initial focus is the Stuart Shelf and the Torrens Hinge Zone, but we will be thinking about the Riff complex and other areas of the Neoprote deposition. So the overall aims are to map the architecture of the basin, map Lithofascis, try to model the key surfaces, which are the target horizons, and really determine the controls on mineralisation. And again, I mentioned that Carmen from the survey is the lead on this project. She has identified key holes and has gone a long way into re-logging these key holes, which are going to be used for tie points to reinterpret the stratigraphy or lithofasces across the Stuart Shelf. So in each of these drill holes, we're collecting loads of data, like the high logger data, portable XRF, and something that was well received over the last couple of days is just a photographic compilation that Carmen's put together of the lithofasces, the sedimentological features, which are, a lot of people have asked for those, because it gives a real guide to explorers coming in to get their head around exactly what these sedimentary rocks are telling us. And in particular, you know, most of us are from a minerals background, and, you know, successful exploration, said copper does require some more soft rock thinking and knowledge. This is a great image that George put together. George Guthis is modelling some of those key surfaces. And some of those are shown there, draped over a depth of basement model. Really, this is drawing out some of the key controls on the mineralisation in this, in the Stuart Shelf, and really, one of the components of the CSIRO project is to try to improve our constraints on some of these surfaces. We also have Geoscience Australia involved from their Geochemistry for Basin Prospectivity project within EFDF2. They're going to be taking 1,000+ samples to characterise source and host rocks and identified fluid pathways as and evidence of alteration across the basin. And something that probably deserves a talk in its own right, really exciting work that CODES have done over the last few years, which is just coming open file now. This is work on pyrite analysis funded by GGO in the past. And they have identified, looking at the pyrite chemistry and lead isotope ratios on the pyrites, demonstrated over a 10-kilometre anomalism in silver out from known mineralisation across the Stuart Shelf, and really interestingly, using those lead isotope characteristic signature, they can identify that a copper-bearing fluid has actually interacted with those rocks. So a really useful early exploration tool. So in conclusion, the Adelaide Super Basin basically has the right rocks. It has all those right mineral systems ingredients, and hosts many of the different variations in styles that you see in the Copperbelt. We have that in South Australia. But I suppose there are some challenges to the discovery of really large deposits, and cover being one of those things. But rather than finish on that, I just want to finish on a couple of opportunities, which really is, if you look at the drill holes within the Adelaide Riff complex, way less than 1% of those are more than 100 metres. So could some of those small occurrences actually be a sign of more significant mineralisation at depth? And lastly, something from Stuart Bull. If you actually look at the approximate size of the Torrens Hinge Zone and put that over the African Copperbelt, it's actually, the Torrens Hinge Zone is the same size as the mineralised segment of that African Copperbelt. And that's something really for food for thought, I think, for people exploring for this style of deposit in South Australia, and does give us some encouragement that the big deposits are out there. Thank you very much.